How's it going, everybody? And welcome back to our NSX-T series where we're discussing the data center lab build. In this video, I'm going to walk you guys through a logical overview of what we're going to be building with the vCenter networking that we're going to be rolling out. So let me go ahead and zoom in. We've obviously got vCenter server deployed at this point. We've added ESXi host to it. We've built the data center. We've added the compute cluster, all that type of stuff. What we're going to be doing next is basically taking and doing the DC1 compute VDS and doing the DC1 edge VDS. And we're going to be migrating from vSphere standard switches over to vSphere distributed switches. And the benefit to that, the benefit to doing VDS versus VSS is that with VDS, it's one switch that's deployed across all the hosts. Now, I thought about building this green box logically across all of them to simulate that. But I decided against that for the simple fact that they all have it, right? It's all the same VDS. So you create one VDS and you add all of your hosts to it. Once the hosts are added to it, any modifications to the VDS, new port groups, modifications to the VDS itself, so on and so forth, affect all the hosts. Because all the hosts are joined to the VDS, they inherit any changes that are made in vCenter on the VDS itself. And that's the real key point here. Now, I'm not talking about ESXi 7, vCenter 7, or NSX-T, where you would be installing NSX-T at the VDS level. That's a different conversation that we'll be having in the future. But as you can see, I've got a series of network adapters mapped to it. I've got 2 for management, 2 for storage, 1 for vMotion, 1 for data. Now, what I specifically did here, and I'm going to go ahead and get out of the way, is I specifically put emphasis this blue lines that are drawn. This blue line that's drawn is interconnecting all of my compute nodes and compute clusters. Is for there's going to be 2 different VDS port groups that we're going to create one for Windows, one for Linux. I put net in front of this just for the simple fact that it's network. One VDS port group for Linux, one VDS port group for Windows. They are both going to be tied to VMNIC5, which is going to be for data. And what that's going to allow us to do is, because it's going to be 2 different port groups, it's going to be 2 different VLAN IDs. We're going to be using VLAN 100 and VLAN 101 based on the 3rd octet and the IP address right there. So once that's done, we're going to have to create subinterfaces on the routers. And this is going to allow us to go through and provide default gateways for the routers, or for the virtual machines that are there. Now, once we have done this, the logic flow is you're going to create the VDS first. Once the VDS is created, you're going to attach a certain number of uplinks. We're going to do 6. Just like the breakdown you see here, we're going to do 2 for management, 2 for storage, 1 for vMotion, 1 for data. VMNIC 6 and 7 are going to be reserved for the NVDS when we go to deploy NSX-T. That's what we're going to go do. So what we'll do on the compute VDS, for every port group that we create, we're going to have to go at the port group level and define how many uplinks each port group will get. So there will be 2 for management, 2 for storage, 1 for vMotion, 1 for data. Now, if you don't have if you don't have enough physical uplinks to do a dedicated service per uplink, that's okay. You can create port groups and have them load balance across both of, or however many uplinks you might have. That's completely okay too. In this case here, I'm using dedicated uplinks because I can add as many as I want. So in this case here, this is going to be a great example of how when you have a single uplink, but you need to allow multiple VLANs to ride across it. This is a perfect example because you're going to have 2 different port groups that are going to need to ride across a single uplink. And as long as the uplink northbound of the distributed switch, this connection right here, as long as this connection right here is a trunk link, which it is because we configured the port group to do that with 4095, because that's there, we're in good shape. Now, if this was a real-world deployment, obviously this vSwitch would not be used. We would be connecting physically to, or I'm sorry, logically, we would be connecting to the vSwitch that has uplinks to the outside world. And then from there, we would be able to provide the VMNIC 0 to the upstream physical device would be a trunk link, and that would allow us to get the connectivity there. So we're basically using the CSR 1000 Vs as a proxy to get from the virtual world to the physical world, but that works. It's going to work out for us. So that's basically what we're going to be building. We're going to create the VDS, we're going to add the port groups to it, and then we're going to specify how many uplinks per port group are needed. Once we have all that laid out, then we're going to add the ESXi host to the VDS. Once the ESXi hosts are added to the VDS, there's a process of migrating, and vCenter does this for us. You have to define what the migration is going to look like. What uplinks are going to get mapped to which VMNICs are going to get mapped to which uplinks, which VM kernel adapters are going to get mapped from the VSS over to the VDS VM kernel adapters, so on and so forth. So all of that has to happen. Once all of that is done, then we'll be able to take that a step further. There's going to be additional VM kernel adapters that are going to be needed in order to do things like vMotion, storage area networking, so on and so forth. So that is the basics of the networking that needs to happen in order for all this stuff to work the way that we need it to. So once all that's done and migrated, then we'll be able to move any virtual machine network adapters that are sitting on a VSS port group to a VDS port group. So you'll be able to do both a uplink, a VM kernel adapter, and a virtual machine networking can all get migrated in one fell swoop. And that's the real benefit to using a VDS versus a VSS. VDS is going to be the way to go. You must be using VDSs and clusters in order for NSX-T to work the way you need to. So you can't do it on a VSS. The capabilities just aren't there. So that, ladies and gentlemen, is everything that I wanted to break down from a vCenter networking perspective and how that's all going to come together. So in the next video, we're going to actually go through and do all of that stuff. If you have any questions, please leave a comment in the comment section below. Please like, share, and subscribe if you haven't already done so, and I'll catch all of you guys in the following video.